We're going to transition into the conversation, and I can't imagine that after hearing these two amazing speakers, each very different, each bringing their own skills and expertise, that you won't have questions, both about what you heard and about the future.
I'm Patricia DeMarco from the Rachel Carson Institute at Chatham University, and I really am very excited about the potential for green chemistry going forward. But we have a legacy of about 800,000 existing chemicals, many of which are indeed toxic and circulating throughout the biosphere. How do we displace that legacy, of which only about 200 have been tested for health effects, and move to a displacing of them with the green chemistry types of products? What are the institutional barriers to making what you're talking about the mainstream option?
I can. Go ahead. I'll be happy to start. There's two things. Number one, we need safe remediation technologies. These things are existent. They are in the ecosphere, as you point out, and we got to get rid of them. And ironically, there's a lot of technologies out there that purportedly do remediation that, in fact, add more problems than solve them. And so the Herculean effort of Terry to come up with green chemistry techniques for remediation technology is absolutely essential. And we need to get rid of all of the things, the legacy compounds that exist already. And then what we need to do is we need to be systematic at getting rid of everything else, but we've got to recognize that the field of chemistry is 150 years old. There's been 150 years of incremental development that's been happening just because we want to. There's no magic green button that tomorrow everything can be safe. And we've got to recognize that the enemy of the excellent is the perfect, you know, and that we need to celebrate incremental improvements. If someone uses something that makes it less toxic but hasn't yet addressed, you know, energy use, instead of saying it's not good, we got to celebrate that and realize someone else has got to work. And the way science works is incrementally. So as long as we kind of grab our hands onto the edge of the seat, recognize we can't demand perfection, and recognize this is a long haul, 20, 30, 40, 50, 60, 70, 80 years, we still are going to be figuring this stuff out. There's a lot of work to go on. So we just got to recognize, again, another great Stephen Covey, you know, quote is, the enemy of the excellent is the perfect. And I think that those two things we have to recognize. Don't create new problems, and be patient as we solve the old problems.
Terry, do you want to add to that?
Yeah, yes, John, that was excellent. The other thing is that things are happening much more quickly. So whereas the identification and analysis and solution of major environmental problems in the 19th and 20th century hardly existed in the 19th and the 20th century, took a very, very long time to do. Things are happening much more quickly now, so I'm optimistic about that. And I think really the big change agent is actually the internet. Because through the internet, people can communicate worldwide very simply without anybody having to stand in the middle and monitor and allow that to occur. And so really the kind of leadership that Pete has given us in bringing the people together and getting them to work together on dealing with, analyzing, explaining the environmental problems is a critical thing. But you are right, we have a huge amount of stuff to do, and unfortunately many of the problematic chemicals that you're talking about are extremely profitable. And so that dynamic is something that we have to work out as well.
I would add one comment to that, which is that I spent a lot of my career dealing with all those 80,000. And constantly, the obstacle we ran into was, well, what's the replacement? Because having a real replacement changes the economic calculation. But the problem is that the replacements that are currently available, for the most part, were designed using the same flawed principles that led to the creation of the bad thing we're trying to get rid of. And that's when I really realized that creating a dynamic growth in green chemistry where they're really focused on not just finding the next little bit better thing, but looking far to the future and saying, how do we create a generation of inherently safe materials? That's the path to getting us away from these chemical by chemical battles to a generational change. We're not there yet, but that's clearly the way forward.
Hi, I'm Con Nugent from Kaplan Fund in New York.
Could you use the
There's a microphone behind you.
Because we really want to capture your words of wisdom, those Irish words of wisdom.
I wanted to know if if you have peers internationally, is there an international network embarking on the same kinds of investigations and the same types of paradigm shifts in chemistry that you are? John, are there places in this globe where they don't have to work quite so hard to get 500 of the 900 institutions with chemistry majors taking that course in toxicology? What's the international setting of this?
That's an interesting thing. This is a global movement. You know, the Presidential Green Chemistry Challenge Award program sets us apart because of this national recognition that makes us appear to, but this is in Europe, this is in Africa, this is in Asia, this is, and just as an example, in India, they are in the process of mandating that all students in India take a one-year course in green chemistry. It's being piloted in Delhi. In China, think about this for a second. In the United States, if you want federal funding to do research in the United States, you better have nanotech somewhere in the title of your talk. All right? $11 billion later, you can't name a university or a program that doesn't have some nano center, some nano this. Is it because scientists woke up one day and said, wow, nano is awesome, or is it because there was $11 billion of funding? In China, if you want federal funding, you got to have green chemistry in the stuff. So these developing economies are ironically ahead of us in integrating this to, and let's be certain, I don't believe this is altruism. This is about competitiveness. They recognize that to be globally competitive, their companies must compete, and because the U.S. isn't doing it, their opportunity is to actually offer, ironically, the environmentally benign technologies and become competitive because of it. Okay, so I see it as a global movement.
John and I, in December, were in Mumbai at Industrial Green Chemistry Conference. There were, the room was full of chemists working for some of India's biggest chemical companies. There was an audience I never thought I would ever in my life address. But there I was, and as I talked to people there, and I listened to what was being said, I realized that a huge amount of motivation for that conference were recent changes in European chemical standards that are making it harder and harder for companies from other places in the world to import chemicals into the European market, which is the biggest market. It's called REACH. And the regulation, the suite of regulations is called REACH. And those Indian chemical companies want access to that market. They see the writing on the wall, and they also see that there's a huge push forward right now to get the intellectual property at basic processes in green chemistry. Basic scientific discoveries that are going to define what green chemistry can do. And also, if you don't own the intellectual property, you're going to pay a lot for it, because you're going to need it just as they need it to get into the European market. So I find, first of all, I'll confirm what John just reported about the existence of a global network and the focus of some of the developing countries on building the educational infrastructure and the research infrastructure that makes it possible. And I'm watching this and I'm saying, this is not good for this country.
So there are countries that have a great deal more research dollars per capita than the United States, a large amount more, and they are aggressively recruiting green chemists, including trying to get people to move from the United States to their countries. You asked about the question of is the toxicity training the same in all countries? It is not. For example, I am told that in Holland, all undergraduates or all students of chemistry have to take courses in toxicology. At the ETH, the premier technical institution of Switzerland, that is also the case. What John is trying to do to get this country to move in that direction is fantastic and absolutely essential.